It didn't send a signal. It didn't slow down. And it's not from here. Something cold, ancient, and impossibly fast has just crossed into our solar system. It's older than Earth, older than the Sun, maybe older than our galaxy as we know it. We've seen mysterious objects before, but nothing like this, because this time we saw it coming. In just the past 8 years, we've watched 3 objects enter our solar system from deep interstellar space. The first was ʻOumuamua, long, fast, and strangely silent. The second was Borisov, a comet that evaporated before we could learn its secrets. Now comes the third, 3I Atlas. And this one? It's bigger, brighter, and moving faster than both of them. But what really has scientists on edge is where it came from. On July 1st, 2025, a sky survey system in Hawaii picked up something strange. NASA's Atlas telescope, designed to scan the skies for objects that might one day hit Earth, flagged a speck moving impossibly fast. That speck was traveling at 130,000 miles per hour, slicing across the sky like a bullet. But it wasn't just the speed. Its orbit wasn't elliptical or even parabolic. It was hyperbolic, with an eccentricity of 6.2. That number meant one thing: this object wasn't from here. It wasn't orbiting the sun. It was just passing through. Within 24 hours, astronomers had confirmed the truth. This was an interstellar comet, the third ever recorded. Unlike ʻOumuamua, which had already exited before we understood what it was, we had caught 3I Atlas on the way in. This wasn't just rare. This was a once-in-a-century opportunity, and every telescope on Earth suddenly had a new target. When astronomers first crunched the numbers, they realized this wasn't just another icy wanderer from the edge of our own solar system. It was big, really big. Current estimates put its diameter somewhere between 11 and 20 kilometers. Even on the low end, that's more than 10 times the size of ʻOumuamua, and it easily dwarfs Borisov, the only other confirmed interstellar comet we've ever seen. But size isn't the only thing making it stand out. For one, its surface activity is strange. Most comets heat up as they get closer to the sun, releasing gas that forms a glowing tail streaming away from our star. 3I Atlas? It's doing something different. So far, telescopes haven't picked up any strong gas emissions at all, at least not the kind we expect from water vapor or carbon dioxide jets. Yet it's still shedding dust. And then there's the tail itself. Instead of pointing directly away from the sun like a normal comet's, its tail appears to be angled oddly, in some early images, even toward the sun. That's not what you'd expect from the push of solar radiation. It suggests that the dust grains might be heavier, larger, or behaving differently under sunlight than usual, a possible explanation for its engine-like thrust. The coma, that faint fuzzy halo of material around the nucleus, is also worth noting. It's there, but it's faint and compact, not the sprawling cloud we often see on active comets. Some researchers think this means it's still too far from the sun to really wake up. Others suggest that if it's rich in certain kinds of ices, we might see a dramatic outburst once it heats up later this year. And here's something few people realize. Before anyone officially discovered 3I Atlas, we'd already captured it in detail. The Vera Rubin Observatory, still in pre-operations testing, had unknowingly taken 49 images of the object. Those archived shots became crucial for reconstructing its motion, confirming that it wasn't bound to the sun and locking down its hyperbolic trajectory. We also have early images from the Hubble Space Telescope. At first glance, they seem to show the nucleus stretched out,
almost elongated, leading some to think it might be spinning fast or tumbling. Later analysis revealed it wasn't the comet itself, it was camera motion during the exposure. Even so, those first close-up looks confirmed the object's brightness and gave us a better idea of its shape and reflectivity. Put all of this together, and you have something that looks like a comet in some ways and completely defies the rulebook in others. And it means 3I Atlas will be under intense watch in the months ahead.
Most comets we've studied likely formed in the same region as the Sun, the thin disk of the Milky Way. It's where the majority of stars, including ours, orbit in a relatively flat, orderly plane. But 3I Atlas breaks that mold. Its trajectory, modeled using data from the ESA Gaia spacecraft, shows it's falling into the solar system at an angle that doesn't match the thin disk. Instead, it appears to come from above, from the thick disk, a vast halo of stars that orbit in a puffier, less structured layer around the galaxy. That's not just a change in direction, it's a change in origin story. The thick disk is older, its stars have less metal, less dust, and far more chaotic motion. It's the ancestral layer of the Milky Way, formed over 9 billion years ago. This means 3I Atlas might be a leftover chunk from a long-dead solar system, shattered billions of years before Earth ever formed. And if that's true, we're not just looking at a comet, we're staring at a survivor, a frozen time capsule from the galaxy's earliest days.
When 3I Atlas was first spotted, the official word came fast. It's a comet. That label was assigned within just 24 hours of its discovery. For something this rare, that kind of speed raised eyebrows in the scientific community. Normally, classifying a new object, especially one from outside the solar system, takes longer. Astronomers need to confirm its behavior, study its spectrum, and make sure it's really acting like what we call a comet. And that's where the doubts creep in. A real comet, in the traditional sense, should vent gas as sunlight warms its surface. That outgassing creates the bright coma and long tail we see in telescope images. But 3I Atlas isn't playing by those rules. And what makes the mystery sharper is the lack of an active plan to study it up close. No space agency has announced a mission to intercept it, despite its size, rarity, and potential to answer questions about material from beyond the solar system. That's a once-in-a-lifetime chance we may be letting slip away. So for now, comet is the official label, but that word might just be the first chapter of a much stranger story. If you plot the path of 3I Atlas through our solar system, something jumps out immediately. It's not just flying by on some random arc, it's threading a needle, weaving through a sequence of planetary encounters that looks almost too neat to be coincidence. From late 2025 into early 2026, this interstellar object will come near Jupiter, Mars, and Venus in rapid succession. None of these passes will be close enough to pose any danger, but the geometry is remarkable. Each encounter places 3I Atlas in a position where multiple spacecraft, telescopes, and planetary probes can get a clear look. It's as if the solar system itself is setting up a photo shoot. And here's where it gets even stranger. The object's inclination, its tilt relative to the plane of our solar system, is just 5 degrees. That's almost perfectly aligned with the launch lanes human engineers use when sending probes on interplanetary flybys. Such low inclination corridors allow for efficient gravity assists, those slingshot maneuvers that use a planet's gravity to change speed or direction without burning fuel. It's exactly the kind of path you'd choose if you wanted to maximize the benefits of planetary flybys. Statistically, the odds of an interstellar object arriving on such a route by pure chance are incredibly low. Some estimates put it at around 1 in 20,000. Of course, space is vast and rare things do happen, but it's the combination that raises eyebrows.
a perfect sequence of planetary passes, a near-coplanar orbit, and timing that gives us multiple observation windows. Natural explanations are on the table. Galactic dynamics could have nudged it into this path long before it reached our neighborhood. Its trajectory might be the result of ancient gravitational interactions we'll never be able to reconstruct. But whether it's a fluke of physics or something more deliberate, one thing is certain: this is the most observation-friendly route an interstellar object has ever taken through our solar system.
The key solar milestone comes in October-November 2025. That's when 3I Atlas will reach its perihelion, its closest approach to the Sun. At that point, sunlight will strike its surface at maximum intensity. If the object is rich in volatile ices, we could see a dramatic increase in activity. Jets of gas erupting, a tail brightening and lengthening, and new material being released into space. If nothing happens, that's equally telling. It would hint at an unusually inert or dust-heavy composition. Then comes December 19th, 2025, the day of Earth's closest view. Even then, it will remain a safe 2 astronomical units away, about twice the distance from Earth to the Sun. That means no threat, but also no naked eye spectacle. For the average person, it won't appear in the sky, but for telescopes, it's a prime moment for close-range study. There is, however, a major challenge: the visibility problem. For much of its journey, 3I Atlas will be hidden behind the Sun from our point of view here on Earth. This solar blackout happens right during a crucial part of its approach, meaning ground-based telescopes will be blind to its activity for weeks, possibly months. But space-based observatories are another story. The James Webb Telescope and Hubble will try to track it in multiple wavelengths, peering through the blackout period from positions far enough from Earth to avoid the worst of the glare. Planetary probes might get in on the action too. Even if they weren't built for this purpose, a lucky pointing of their cameras could net valuable data. For example, ESA's JUICE at Jupiter, NASA's Psyche mission in deep space, and even some Mars orbiters might catch opportunistic images or spectra as it passes within range.
If this is the kind of discovery that gives you chills, hit subscribe. We're just getting started.
3I Atlas isn't just a comet, it's a scientific opportunity that may not come again for generations. Because if this object really is as old as early models suggest, 8 to 9 billion years, then it's older than Earth, older than our Sun, and older than most planets in the galaxy. It may contain chemistry frozen in time from a star system that no longer exists. Scientists want to know: what is it made of? How much water does it carry? What kinds of organic molecules might be trapped inside? The James Webb Space Telescope, with its infrared sensors, could detect carbon compounds, methane, or even amino acids, building blocks of life. Hubble might reveal details of its tail structure, rotation, or how it interacts with solar wind. And ground-based observatories will be watching for subtle changes in color, brightness, and spin. Together, all these data points could help us understand how solar systems evolve, how elements travel across the galaxy, and whether our chemistry is universal or unique.
Of all the explanations for 3I Atlas, one is guaranteed to spark heated debate: the idea that it might not be entirely natural. It's in this space of uncertainty that Harvard astrophysicist Avi Loeb's earlier arguments about ʻOumuamua resurface. He suggested that ʻOumuamua could be a form of alien technology, perhaps a probe or fragment of a larger construct. Some of the criteria he outlined – unusual trajectory, lack of typical comet emissions, potential non-gravitational acceleration – are now being discussed in relation to 3I Atlas. So far, there's no confirmed evidence of course corrections or artificial propulsion. But astronomers are watching closely.
If telescopes like James Webb or Hubble detect even a slight acceleration inconsistent with gravity alone, it would immediately reignite the alien probe debate. Mainstream scientists urge caution. They point out that extreme claims require equally extreme proof. And right now, all we have are anomalies, not answers. Unusual natural comets do exist, and it's possible that 3I Atlas is simply one of them, shaped by billions of years of interstellar travel. Still, with its size, age, rare trajectory, and precision flyby sequence, this visitor stands apart from anything we've seen before.
For most of human history, the idea of an object from another star system passing through our cosmic neighborhood was pure theory. Before 2017, not a single confirmed interstellar object had ever been seen. Then came ʻOumuamua in 2017, strange, fast, and unlike anything we'd expected. 2 years later, in 2019, we spotted 2I Borisov, a much more traditional-looking comet, but still from beyond the solar system. And now, in 2025, we have 3I Atlas, bigger, faster, and potentially far older than the first two combined. That's 3 in just 8 years. From 0 in all of recorded history to a sudden surge? Coincidence? Or the start of something bigger? Part of the answer lies in our improved eyes on the sky. Survey programs like NASA's Atlas, Pan-STARRS, and the newly operational Vera Rubin Observatory are sweeping the heavens with unprecedented sensitivity. Rubin's archived pre-discovery images of 3I Atlas show exactly how far we've come. A decade ago, we simply wouldn't have spotted it until it was already leaving. But some astronomers think it's not just better telescopes. They suspect the solar system itself might be moving into a denser region of the galaxy, where the gravitational pull of nearby stars or hidden galactic structures sends more debris in our direction. If that's true, the sudden spike in detections could be more than just a technological artifact. It could be the start of a long-term interstellar traffic jam.
What if comets like 3I Atlas aren't just messengers, but midwives of life? There's a theory called panspermia, the idea that life, or at least its basic ingredients, didn't start on Earth, but arrived here riding frozen rocks from space. We've already found amino acids inside meteorites. We've seen complex organics in the tails of comets. And now, here comes 3I Atlas, carrying materials that formed around a star long extinct. If this object holds carbon chains, methanol, formaldehyde, or even prebiotic molecules, it could confirm that the building blocks of life are not unique to Earth. They're scattered across the galaxy. And if that's true, then life didn't begin here. It just stopped here for a while.
3I Atlas might be the most exciting interstellar object we've found so far, but it won't be the last. The Vera Rubin Observatory, a massive next-generation telescope in Chile, has just come online. With its wide-angle lens and rapid scanning system, Rubin is expected to find hundreds of fast-moving objects every year, some of them interstellar. In fact, astronomers believe there may be 10,000 interstellar objects inside our solar system right now, dark, silent, drifting through space unnoticed. Soon, we won't just be guessing where these objects come from. We'll be tracking them. We'll be classifying them. And one day, we may even catch one.
3I Atlas didn't come with a message. It didn't blink. It didn't stop. But its presence speaks volumes. It's been drifting through the void for billions of years, untouched, unchanged, until now. We may never know what system it came from. We'll likely never see it again. But for this fleeting moment, across the vast emptiness of space, it came here. To our corner of the galaxy. To our sun. To us. And whether it's a natural wanderer or something more, one thing is certain. It reminds us how little we know and how much more is still out there, waiting.
If you want to see what else the universe is hiding, stick around. This is just the beginning. Subscribe for what comes next.